Okay, now we're going to look at another way to solve quadratic equations, which is using your quadratic formula, which again is something that you have done before. So first of all, you need to make sure that you write down your quadratic formula that I have here. Now the A, B, and C, just a quick reminder, when your quadratic is in standard form, as I had given you on a previous lesson, the A is always going to be the coefficient of x squared, B is the coefficient of x, and C represents your constant. So you would always want to have your equation in this form in order to use your formula. So for this particular problem, my A value is 1, my B value is 8, and C is 12. So we just need to take these values and substitute into this formula. So I would have negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 12, all divided by 2 times 1. Okay, just use your calculator to assist you with the value that you would have here underneath your radical, and that's going to end up being 16. Of course, 2 times 1 is 2. Now you can take the square root of 16. Of course, that's a perfect square, which is just going to give us 4. Now, in some cases, once you get to this step, you're finished when there happens to still be a radical left. But since this was a perfect square, I don't have my radical. Go ahead and do the two calculations, like work this out with the plus sign, work it out with the minus sign. So using the plus sign, negative 8 plus 4 is negative 4, and then negative 4 divided by 2 is negative 2. So there's one of your answers. And now using the minus sign, negative 8 minus 4 is negative 12, divided by 2 is negative 6. So there's your two answers. So sometimes it'll work out where you actually end up with rational answers. Sometimes your radical will still be left where you have irrational answers. Okay, next one. All right, now on this one, first of all, before I identify A, B, and C, I need to get it in the correct form, the standard form that we had talked about before. So I'm going, you can get 0 on either side, it doesn't matter. I'm just going to shift everything to the left. So I have 3x squared minus 6x plus 1. Okay, so now my A value is 3, B is negative 6, and C is positive 1. So substituting those into my quadratic formula, I would have negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 times 1, and that's all divided by 2 times 3. Okay, so of course that's going to end up just being a positive 6. Okay, again, underneath your radical, that's going to end up giving us, what, 24, I believe. Yes. Square root of 24 over 6. Now, 24 is not a perfect square, but it can be simplified. And I'll just come over here to the side. The largest perfect square that will go into 24 is 4. So you'd break it up as 4 times 6. So square root of 4 is 2. The 6 is left underneath, and then you've got the 6 on the bottom. So this is where I was talking about a while ago. Sometimes you will have a radical, which would actually mean here this is an irrational answer. Now, there is a step of reducing that you can do here. You won't always be able to do this, but these three numbers here that I'm pointing at, this does not include the number under the radical, but if you can reduce all three of those by the same factor, then you are expected to reduce. So that would be reduced by 2. So 3 times, 1 time, 3 times. So my final answer is 3 plus or minus square root 6 over 3. Now you cannot come back and cancel the 3's. Okay, you can't ever do any reducing here unless it's all 3 of them. So there's your final answer on that one. Alright, one more problem. This is an application problem using your Pythagorean theorem that you're used to, which is a squared plus b squared equal c squared. Okay, so I have a rectangular park that is 6 miles long and 3 miles wide. So how long is a pedestrian route that runs diagonally across the park? So you can draw a picture here if need be. So we got a rectangular park, 6 miles long, 3 miles wide. Now, the route, the pedestrian route, is the diagonal, so you can draw the diagonal whichever direction you want. I'm going to dot it in this way. So what ends up happening is half of this, whether it's this half or this half, doesn't matter, but you end up with a right triangle. And if you remember, that's where you can use your Pythagorean theorem to determine the side of a right triangle. Now the A, B, and C, if you remember, it's the diagonal that has to be the C in your formula, which means these two are the A and the B. Which one's which doesn't matter. So I'm just going to let this be A and let this be B. So I would have 6 squared, 6 squared plus 3 squared is equal to C squared. So this is the C. Okay, so if I do the 6 squared plus the 3 squared, that will give me 45. Okay, now your next step is going to require that you take square root of both sides. That's why this is in that section, because you're using your square root property. So that's going to give me C is equal to plus or minus square root 45. Now, first of all, you would actually just ignore the negative, because the length across the park is not going to be a negative number. Okay, so if you didn't put the plus minus and just kept it as the positive, that's fine. The other thing is that you're going to see on this is they're going to look at this as a decimal, because it doesn't make any sense to say, well, the distance is 3 square root 5. You know, it's going to make more sense to look at it as a decimal. So just use your calculator, square root of 45. So if I just go to one decimal place, my answer would be 6.7 approximately. So 6.7. And again, that's just approximate. Of course, that's in miles. So there's your answer to that one.